Hello, dear students. Welcome to Ark Institute. I am Dr. R.K. Saini. As you know, your JEE Advanced examination is just a few days away. This is the most crucial phase of your preparation. What you do in these final days can make a significant difference in your result. To support your preparation, I am uploading high quality JEE Advanced level paper focused on organic chemistry. These papers are carefully designed based upon previous JEE Advanced pattern and include all important type of questions such as single correct, multiple choice, matrix match, paragraph based, assertion reason, and integer type. I strongly recommend that your attempt these papers seriously, just like the actual exam, and analyze your performance honestly. This will help improve your confidence, speed, and accuracy. Stay focused, stay consistent, and give your best effort. Let's make these final days truly count. Now, I start to explain your mock test in detail. For example, question 1 to 8. In this section, question 1 to 8 single correct answer, and each question carry 3 marks and with negative marking. Question number first. Compare SN1 reaction. Compare rate of SN1 reaction. We know that SN1 reaction depends upon the stability of intermediate, particularly types of carbonium ion. It is carbonium ion and the carbonium ion and the carbonium ion. And we know that most stable carbonium ion will easy form and fast form. Therefore, the rate is high. And hence, in second, it is the aromatic species, particularly tropylium cation. The rest second is highest, then non-aromatic, and this cation is anti-aromatic, highly unstable, therefore very slow rate in third, therefore option fourth. In question second, it is the addition reaction, and in this addition reaction, this reaction is also known as Diels-Alder reaction. In Diels-Alder reaction, diene react with dienophile and make a six-membered ring. Six-membered ring, no cation, no anion, no free radical, is an intermediate species. Simultaneously takes place cleavage of the bond, and formed a cyclic ring. Simultaneously formed a cyclic ring. The double bonded compound is known as dienophile, and double bonded ene is known as diene, and make it dienophile. In this compound, in dienophile, the configuration of compound is trans. Therefore, in product, the compound is also trans. Also trans means this group, one group of the ester and the another group of ester are just opposite to each other, and hence in option second, group ester groups are just opposite. One is dotted and another is thick, means are opposite to each other, and it is the mechanism of Diels-Alder reaction. Question number next. Question third. How many among the following does not give positive test? Positive test with failing solution means the compound are non-reducing in nature. First, acetic acid does not give positive test. Sucrose does not give positive test. Benzaldehyde, because aromatic aldehyde are also not give test with failing solution. Important notice, aromatic aldehydes are more stable and does not give test with failing solution, and acetone. However, formic acid give this test because formic acid hidden aldehyde group is there. Therefore, formic acid give this test rather than other monocarboxylic acid like as acetic acid, propanoic acid. And as four compound, acetic acid, sucrose, benzaldehyde, and acetone does not give this test. Next, which of the following is most stable? First, for check the stability, first we find nature of species means aromatic, non-aromatic, and anti-aromatic, and then we check octet of second period element or neutral species. In species first, This positively charged carbonium ion, is unstable due to incomplete octet. In second is also incomplete octet. In third, this carbon, and in oxygen carry positive charge. However, the octet of carbon is complete. But in example 4, more conjugated double, single, double, single, double, single, and all atoms complete their octet. However, the positive charge present at the nitrogen, but their octet is complete. And hence, fourth one is most stable species. Question number 5th. Question 5th comes from biomolecules and the reactions of glucose with different reagent are taking place. For example, in reaction first, reaction of glucose and the product. In hydroxylamine, when hydroxylamine react with aldehyde, then the product are known as oxime. Hydroxylamine NH2OH. Therefore, the reaction first, hydroxylamine will give glucoxime. Next, bromine water. Bromine water is weak oxidizing agent, or I can say it is not a so much strong oxidizing agent, and hence it oxidizes only aldehyde group into acid. Therefore, the product is gluconic acid first. And in excess of acetic anhydride, we know that in glucose 5 OH group are there. Therefore, pentaacetates are formed. And in concentrated HNO3, it is a strong oxidizing agent rather than bromine water. Therefore, primary alcohol as well as aldehyde, both groups are oxidized, and it gives saccharic acid. Primary alcohol at last carbon, and aldehyde at top carbon. Therefore, the product is saccharic acid. Option number 3rd. Question number 6. Reaction of aniline with chloroform and KOH. We know that chloroform and KOH make intermediate species is dichlorocarbene. It is electrophile. It is electrophile due to incomplete octet. And in this reaction, the nitrogen is strong nucleophile than benzene ring. Or we can say this electrophile cannot be attack benzene ring, but it attack at NH2 group, because nitrogen is more strong electron donor or strong nucleophile center. Therefore, isocyanide is final product. And hence, the reaction is known as carbylamine test, because the isocyanides have offensive smell. Therefore, this reaction used for the test of primary amines. This reaction give aliphatic as well as aromatic, and hence the product are wrong. But in statement second, aniline give phenyl isocyanide, the reaction in above and this. Therefore, the statement 4th is correct. Next, question number 7. Which of the following reactant will give acetone on their ozonolysis? Ozonolysis means the acid gives acetone. We know that the pi bond cleavage and mix and double bonded and carbon change into double bonded oxygen. Therefore, in compound second, this part change into acetone. And hence option second. Question number 8. It is also important reaction. Aniline react with concentrate HNO3 and H2SO4. It is the nitration. We know that aniline is a basic and nitrating mixture is an acidic, and hence maximum part of the aniline are changed into anilinium ion, and we know that anilinium ion is meta directing. Therefore, ortho, meta and para all product are formed, and we know that meta of yield is also obtained in high amount. Product para is highest 51%, meta is 47%, and ortho only 2% in this reaction. This data given your NCERT book and many times asked in JEE Advanced as well as in NEET. Therefore, you remember this reaction or learn this reaction. And as meta nitroaniline is greater than ortho nitroaniline is correct option. Question number 9. Which of the following compound easily undergo decarboxylation? Means easily remove CO2. We know that beta keto acid are easily decomposed on heating and they evolve CO2. And similarly, 1,3-dicarboxylic acid are all easily decomposed on heating and they change into monocarboxylic acid. Monocarboxylic acid. Therefore, compound B and C are easily decomposed on heating and they evolve CO2. Question number 10. In question 10, some compounds are there and we select correct statement A, B, C. The rate of E1 reaction is this is the correct order because E1 reaction depends upon the nature of carbonium ion. In compound first, the carbonium ion is tertiary, is E form in second and is primary. Therefore, first option is correct. And E2 is also correct because in E2 mechanism, leaving group means bromine and deprotonation are simultaneously takes place in opposite direction and hence alkene characters are there. Therefore, for alkene character, tertiary alkyl halide give maximum yield because tertiary alkene is more stable. Therefore, this option is also correct for E2. And the SN2 reaction depends upon the steric crowding. Therefore, steric crowding is least in C option. Therefore, the compound C react fast in SN2. There and hence option third is incorrect. In rate of SN1, fourth option is also fast because this rate also depends upon the nature of carbonium ion because in SN1 the carbonium ion is an intermediate and hence this option is also correct. 1, 2, 4. Question next is paragraph based. Two questions are there. First, electrophilic substitution. Electrophilic substitutions are the characteristic reaction of aromatic compound and hence benzene react with N-propyl chloride in presence of Lewis acid. Therefore, the product is mainly cumene because the carbonium ion is primary. Due to hydride shift, it change into secondary. Hydride shifting, it change into secondary and hence the major product is cumene or I can say isopropyl benzene. And this reaction and the reaction with oxygen, heating and hydrolysis very important because it is the method for the formation of phenol at industrial level. Oxygen react with isopropyl benzene or cumene, then change into hydro compound, then change into hydroperoxide, like as this compound CH3 OOH on heating with acid, then acetone remove from this part and the phenol is the one product. So we identify P is isopropyl benzene and phenol is given, therefore Q is acetone. Option third. Question number 12. In question 12, the given alkyl halide react with ethoxide ion in ethanol on heating. It means elimination reaction takes place. In strong base, in presence of strong base, E2 mechanism takes place. And we know that E2 mechanism is an anti-mechanism. Means leaving group Br and H must be are anti-parallel to each other. But in adjacent carbon, no alpha H. This H, beta H is same side in the Br. Therefore, this hydrogen is not eliminated during the process and hence H removed from this methyl. Therefore, exocyclic double bond is there and hence product second is correct. In this reaction, the HBr is eliminated via E2 mechanism because in presence of strong base, alkyl halide undergo toward E2 and E2 is the anti-elimination in which leaving group Br and hydrogen should be are anti-parallel to each other in transition state. Therefore, multiple bond away from the 5-membered ring and in final product double bond with conjugation with CO means it is more stable. Question number next. Question 13. Question 13 is matrix match type. In compound A, the reaction with sodamide. We know that sodamide is a strong base and hence E1CB reaction takes place. E1CB means hydrogen and halogen elimination takes place. In step first, hydrogen eliminate and then removal of Cl, but both are must be anti-parallel to each other. But in this compound, Cl and H are in same side because Cl and Cl are anti-parallel in all types, therefore no reaction, and hence in compound A does not react with sodamide. Therefore, the option A means no reaction. We consider in case second. This compound react with concentrated H2SO4. We know that concentrated H2SO4 protonated alcohol and eliminate water and make carbonium ion. This carbonium ion rearrange and change into this carbonium ion, and after deprotonation we obtained benzene as a product. After deprotonation we obtained benzene, and hence after removal of H plus ion means formation of carbonium ion means E1 reaction and the major product of aromatic compound. Therefore, for B, compound B, Q and R are correct. In case of C, NaI and acetone, we know that NaI in acetone, the also a nucleophilic substitution SN2 reaction. Therefore, the halogens are replaced by iodine in opposite plane. When we know that vicinal diiodide are unstable and they eliminate iodine via E2 mechanism, and hence the final product is also benzene. All chlorine are replaced by I, and we know that vicinal diiodide are unstable and hence they undergo E2 mechanism, elimination I2. Therefore, E2 mechanism and the major product is also aromatic for C, P and R. And in compound D, bromobenzene react with potassium amide in liquid ammonia. We know that it is also very important reaction because the halobenzenes are inert toward the SN reaction, but in presence of strong base, they undergo elimination addition. First they eliminate HBr and then added ammonia, and hence the final product is aniline. And the mechanism via benzene, intermediate is benzene, and we know that in benzene nucleophile means any ammonia can be attacked at the carbon which contain leaving group or their adjacent, and such type reaction is known as sign substitution reaction takes place. Major product is also aromatic and sign substitution reaction takes place. Therefore, for compound D, aromatic product and sign substitution. Next question number 40, or we can say now we discuss integer type of questions. Question 14. The number of meso compound formed in given compound. For meso compound, we know that compounds must be contain plane of symmetry, and plane of symmetry in which compound equally divided into two halves and both halves are mirror images to each other. Only one plane of symmetry, therefore one meso compound is there. Only one plane of symmetry and one meso compound. Sum of the alpha hydrogen and alpha beta. First, we consider reaction mechanism first. We know that alcohol firstly protonated by H plus ion. On heating, it eliminate water and change into carbonium ion, and then removal of H plus ion. Therefore, this alkene is formed in reaction first, and total this alkene and total 3 total 12 alpha H are there. In reaction second, first we make carbonium ion by the deprotonation of alcohol group and then by the removal of water. This carbonium ion is a primary and hence change into secondary by 1,2 shifting. 1,2 shifting in first step. In another shifting takes place because secondary change into tertiary by 1,2 shifting also. Therefore, in compound second, this cation is formed, and after removal of H plus ion from adjacent, the major product of this alkene, and this alkene contain 9 alpha H, 3 and 3. In last compound, First make carbonium ion, similar like as other, by deprotonation, and in which rearrangement takes place. First we make carbonium ion primary. After 1,2 shifting, it change into tertiary carbonium ion. It change into tertiary carbonium ion. Both, if migration of 1,2 shifting takes place, then equal stability of carbonium ion and hence no migration takes place. And in this last final eliminate H plus ion. And hence this alkene is also contain 12 alpha H. Therefore total 33 alpha H in A, B and C total. Question number 16. How many of the following reaction is primary amine as a final product? Primary amine. First reaction first is primary amine because cyanide reduced by LiLH4 and give into primary amine CH2 NH2. Therefore reaction first. In reaction second, very important reaction, it is known as Hofmann degradation reaction. Amide react with Br2 and KOH in which CO, finally carbonyl group, eliminate from the molecule and change into primary amine. Therefore reaction second. In reaction third, it is also very important, it is known as symmetry reaction. When acid, carboxylic acid react with hydrozoic acid in presence of H2SO4, then finally they eliminate CO2 and N2 and finally change into primary amine of one less carbon atom. Therefore both reactions are known as degradation also. First Hofmann degradation, second Schmidt degradation. In fourth reaction, Beckmann rearrangement takes place, and hence by the Beckmann rearrangement we obtained an alkyl, or we can say an ethyl amide, and then it is not give primary amine. In fourth reaction, alkyl halide react with ammonia in excess. Therefore the product is primary amine only, primary amine, because ammonia is in excess. Secondary, tertiary or quaternary salt are also formed if alkyl halide is in excess, but in ammonia excess we obtain only primary alkyl halide. In reaction second, Grignard reagent react with active hydrogen containing amide. Therefore the final product is methane, and hence only total 4 reactions are there in which reactant or substrate are changed into primary amine. Overall key of this paper is there. Thank you. Okay, bye.